This is Calc 2 final of spring 23, I believe. Compute the following integral. So this is a pretty basic integration by parts. Whatever comes first, we'll set as u. U is equal to, do we see a law? We do, so ln x. du will be equal to 1 over x dx. So dv is going to be equal to 1 over x squared, which is equal to x to negative 2. So v will be equal to 1 over x, or negative 1 over x. Yeah, this is dx here. So applying integration by parts formula, we're going to get a negative 1 over x ln x minus integral. Actually, this will be a plus integral because this negative. Integral of 1 over x squared dx. So it'll be 1 over x, negative 1 over x ln x plus integral of that is going to be 1 over negative 1 over x, so it's going to be negative 1 over x plus c, or not plus c, it'll be evaluating from 1 to e, so this is going to be equal to negative ln e over e minus 1 over e minus ln 1 over 1 minus 1 over 1. Ln e is going to be 1, so it's going to be a negative 1 over e minus 1 over e. This is going to be equal to 0, and this be a minus 1, so it'll be a plus 1. And this is your answer. Okay, so this is in a form of like x squared minus a squared, which correlates to using a trig sub of, what is that? I haven't done this so long. It's x minus secant, I think. Secant theta, yeah, that should be right. So we set x equals to a secant theta. A is going to be 2 secant theta. So dx will be equal to derivative of secant is going to be secant theta tangent theta d theta. So replacing this in, we're going to get x squared, which is, this is x, so it's going to be 4 secant squared theta minus 4, all divided by x, but x is equal to this, so let's replace that here, secant theta, and a dx, but our dx is equal to this, so let's replace that too, 2 secant theta tangent theta d theta. Notice this, and 2, and this 2 will cancel. So now let's focus here. This will be a 2, but this will be basically equal to like square root of 4 secant squared theta minus 1. And this 4, we can bring that on front. And then secant squared minus 1. So we have sine plus cosine is equal to 1, where sine squared plus cosine squared is equal to 1. Sine plus cosine squared is equal to 1. Right? And then if we divide everything by cosine squared, you're going to get sine over cosine, which is tangent squared, plus 1 is equal to secant squared. So secant minus 1 is going to be tangent. So this is going to be tangent squared theta all over, well, we said this cancels and this cancels, so it'll just be tangent theta d theta like this. Here, we can bring the 2 on front. Square root of a square is just whatever it's on the inside, like this, times another tangent, so this tangent would be squared d theta. And earlier we said that tangent theta is equal to secant squared theta plus 1 d theta, which will be pretty easy to integrate because integral of secant squared is going to be tangent theta plus integral of 1 is going to be theta. And we started out with x, now we're in theta, so we need to revert this back to x. So we notice from here that x is equal to 2 secant theta, we notice that secant theta is going to be equal to x divided by 2. Secant is equal to 1 over cosine theta. Cosine is equal to adjacent over hypotenuse. So this will be equal to hypotenuse over adjacent. So if we draw a triangle with this being theta, our adjacent is going to be equal to 2. And our hypotenuse is going to be equal to x. Which makes this side, by the Pythagorean theorem, makes this side x squared minus 4. So replacing theta with what it is, we're going to have 2. Actually, this will be like this. I forgot the square or the parentheses. So we're gonna have 2 tangent theta. Tangent is going to be opposite of adjacent, and opposite is x squared minus 4, which we just found, over 2, which is adjacent, plus theta. Theta is gonna be equal from here. From here, we can see theta will be equal to arcsecant of x divided by 2 plus c. That should be your answer. Okay, so seeing something like this, we can try the trig, like, identity stuff. So, for example, if we let sine stay the same, but cosine squared t times cosine t dt, if we group this like this, and we know that by Pythagorean identity, sine squared plus cosine squared is equal to 1. So cosine squared will be equal to 1 minus sine squared. So everything stays the same here. And 1 minus sine squared theta, or t, sorry, times cosine t dt. We have something like this from this identity. From here, we'll say u is equal to sine. So du would be equal to derivative of sine, which is going to be cosine t dt. And you see, since this is cosine, and this cosine will cancel out. So it will be the integral of sine cubed, but sine is u, so it would be u cubed times 1 minus sine squared. Sine is u, so it would be u squared. And this cosine cancels, leaving us with the du. Now that we have this, we can do this minus u to the 5th power du. So integrating this is pretty basic. 4 minus u to the 5th power, u to the 6th power, u to the 6th power divided by 6 plus c. And now we started with t, but now we're in u, so we need to replace u with what it is. And u is sine. So sine to the 4th power t divided by 4 minus sine to the 6th power t divided by 6 plus c. And that should be our answer. Okay, decide whether the following integral converge or diverge. If the integral converge, you don't need to compute it. Make sure to show correct notations, including showing work for any limits. If you use the theorem, clearly state so. This is a pretty easy comparison theorem type of thing. Once you do calc 2 enough, you should know this immediately. So immediately starting off, we can write this. X to the 6 plus 8. So this right here will always be smaller than 2 over square root of x to the 6. If this is true, and this is going to be equal to x to the 3rd power. So by this, we need to say and we say this is equal to b of n. Actually, we don't need to say that. We need to say the integral from 1 to infinity of 2 over x to the 3rd power dx will converge by p-test, where p is equal to 3. So by comparison theorem, the integral from 1 to infinity of 2 over square root of x squared plus 8 dx will converge. So because this works, because since this is bigger than this, if the bigger term converges, the smaller term must converge, or the smaller function, I guess, must converge. Solve the following differential equation. This is a very basic, like, there's no, like, trick to this. This is just a basic linear differential equation. Like, you don't have to solve for anything, or, like, manipulate the equation before you start solving it. You can immediately see this is your integrating factor. Negative 3 over x. Take the integral of this, e raised to the integral of this. This will be equal to e to the negative 3 integral of 1 over x dx. This will be equal to e to the negative 3 ln of x. And this will be equal to e and ln will cancel, so it'll be x to the negative 3 power, which will be 1 over x to the third power. Now we have this, we can say this is equal to mu. So multiplying everything by mu, we're going to get this. Mu y is equal to x to the fourth power times mu. Applying our knowledge on inverse, like separable, what's it called? Inverse, like implicit differential equations, we will know we can do this. Mu times y will be equal to x to the fourth power times mu. Now integrating both sides, why does that look so ugly? Integrating both sides, based on some fundamental theorem of calculus or whatever, the integral of a derivative is just whatever's on that side. So it's going to be mu times y. We can write out mu at this point. Y over x to the third power will be equal to. Now this is slightly a bit more complicated than this, but it's not very hard. X to the fourth power divided by x to the third power dx. This will be equal to the integral of x dx. Okay, so from this, the integral of this will just be equal to x squared divided by 2 plus c. So y is equal to x to the third power, which will be equal to x to the second power divided by 2 plus c. And when y is equal to 1, when x is equal to 1, y is equal to 5. So 5 over, wait, did I say 1? Yeah. 5 over 1 will be equal to 1 over 2 plus c. This will give us c is equal to 5 minus 1 half, which is 4.5. So now we can plug that in. Y divided by x to the third power will be equal to x squared divided by 2 plus 4.5. Now solving for y, we will get x squared divided by 2 plus 4.5 all multiplied by x to the third power, and this will be your answer. Okay, find the general solution of this. Okay, so we just had a linear differential equation. We're probably going to have a separable, and yes, here we have a separable equation. This is a pretty straightforward, basic separable equation. So you're going to have 1 over, if you take dx, multiply over, take this, multiply to the other side, separating y and x, putting y's on one side, putting x on the other side, you're going to get 1 over e to the 2y. dy will be equal to x squared dx. Now that we have this, we can just integrate it. It's pretty basic here. This will be equal to, well, you can rewrite e to the, or 1 over e to the 2y, like this, e to the negative 2y. Now integrating both sides, we're going to end up with e to the negative 2y divided by negative 2 will be equal to x to the third power divided by 3 plus c. Now that we have this, does it, yeah, it says solve for y, so we need to solve for y here. Solving this for y, what will we get? We go, okay, so we will have e to the negative 2y will be equal to x to the third power. Multiplying both sides by negative 2, we're going to get negative 2x to the third power divided by 3 plus will be minus 2c. and then take ln of both sides. Ln of both sides will leave us with a negative 2y will be equal to ln of negative 2x to the third power divided by 3 minus 2c. And then we just divide everything by negative 2. Or we can multiply by 1/2, I guess. Y is equal to negative 1/2 of ln of negative 2x to the third power divided by 3 minus 2c. Seems pretty simple. Okay, next one. Hopefully I didn't do this wrong. If I didn't do anything wrong so far, that'd be quite embarrassing because they're all kind of easy. Wait, determine whether these... Okay, determine if this is convergent, divergent, or conditionally convergent, or whatever. We do not need to compute its value. Okay, this is a pretty straightforward one. Looking at this, we can immediately think of... Okay, so if you... Okay, yes. So if you look at this, if you just get the highest power term, n to the fourth power, take the square root of this, plus blah blah blah. We don't need to worry about that right now. And the bottom, the highest power is going to be 4n to the third power plus blah blah blah. So if you're looking at this, this is equal to n to the second power over 4n to the third power. This is not a correct, you can't say this, but you can look at it, view it as this. Don't write equal sign because it's not true. Looking at this would know immediately this is going to be, once you apply limit comparison test, you're going to get 1 over 4, 1 over 4, which doesn't equal to 0, which is good. So in b of n will be equal to 1 over n. And since this diverges, this will also diverge. So we already know the answer without even doing any work, which is pretty good, I guess. So I guess we can say, and I know this really fast because I've done a lot of these problems and they're all the same thing literally. So our b of n will be this. And since we're using the limit comparison test, we need to say they're both positive. So let's say a of n is equal to square root of n to the fourth power plus 2n squared plus 6n divided by 4n to the third power plus 2 square root of n plus 8. And our b of n is equal to 1 over n. And we have to say a of n and b of n are positive. Positive terms, whatever. We have to say this, and we can apply limit comparison test on this. The limit as n goes to infinity of a of n divided by b of n will be equal to oh, how do I do this? The limit as n goes to infinity of square root of, okay, let me think here. This will be n to the sixth power plus 2n to the fourth power plus 6n to the third power divided by, so basically what I'm doing is taking this, multiplying it by this, or dividing it by this, so you're just flipping this upside down, and you're just multiplying like this. You're multiplying like that, basically. Multiplying this n, and then the bottom will stay the same because they're multiplying it by 1. This will be equal to, if we multiply top and bottom by 1 over n to the third power, this will give us, actually I don't want to write it here, I want to write it on the bottom. The limit as n goes to infinity of 1 plus 2n, no, 2 divided by n to the second power plus 6 divided by n to the third power divided by 4 plus, okay, so n to the 1/2 power divided by n to the third power is going to give us what? 2.5? 2 divided by n to the 2.5 plus 8 divided by n to the third power will be equal to, okay, well this would just be equal to 1/4 because this term goes to 0, this term goes to 0, this term goes to 0, this term goes to 0. So square root of 1 over 4, which is going to be equal to 1 over 4, which doesn't equal to 0. So by limit, actually, I want to write it like this. Since the summation as from n equals 2 to infinity of b of n diverges by harmonic series. 1 over n is harmonic series, where you can say p test where p equals 1. Harm series. Therefore, the summation as n equals 2 go to infinity of a of n will diverge by limit comparison test. Okay. This question won't be on the midterm, so we don't need to do this one. Consider the series this. Okay, determine the radius. Okay, this is a very basic thing that pops up on literally every single like test. It's just a ratio test. So to do this, we'll do the limit as n goes to infinity of a of n plus 1 divided by a of n, which would be equal to the limit as n goes to infinity of 6n plus 1 times x plus 2 to n plus 1 all over n to the 4th power times a of n, which will be this, but you can flip that by multiplying by n to the 4th power divided by 6n x plus 2 to n power. So this will be equal to the limit as n goes to infinity, blah blah blah. 6n and this will cancel, leaving us with a 6 on top. This and this will cancel, leaving us with a x plus 2 on top. And then this, wait a minute, this is not right. I didn't do that. I messed this up. Wait a second. This is a n plus 1 to the 4th power. This and this does not cancel. Therefore, they'll just stay as it is. Okay, there we go. Now that we have this, we can say, we can group these together. So 6, absolute value of x plus 2, the limit as n goes to infinity of what's left over, which is going to be n to the 4th power divided by n plus 1 to the 4th power. This right here is going to be equal to 6 absolute value x plus 2, the limit as n goes to infinity of multiplying this top and bottom by 1 divided by n to the 4th power. I don't want, it's like, on the bottom it'll be like this. Okay, multiplying this, we will get, what, 1 over 1 plus 1 divided by n to the 4th power, which will be equal, this will go to 0, so which will be equal to 1 over this term right here. What am I doing? This term right here will be equal to 1 over 1 to the 4th power, which will just be equal to 1. So therefore we can ignore this term, which will just leave us with 6 absolute value of x plus 2. We want this less than 1, because if it's less than 1, it'll converge by ratio test. So we want this less than 1. We can take the 6 and divide it over. So we get an x plus 2, absolute value x plus 2, is less than 1 over 6. And our radius of convergence will be equal to 1 over 6. And that's all it asks for. Now it asks us for the interval of convergence of the series. So to do this, we know that the absolute value function thing is like a piecewise function where x plus 2 is less than 1 over 6, but also negative x minus 2 is less than 1 over 6. Okay, now we can just solve this. This is pretty simple. Subtracting 2 over 2, 1 over 6, this would be 12 over 6. So it'll be 1 over 6 minus 12 over 6, which would give you, what, negative 11 over 6. So x is going to be what? Less than negative 11 over 6. So for the second one, we're going to do add it. We're going to add it over. We're going to get 13 over 6. Negative x is less than 13 over 6, which would be, and then divide by negative 1 on both sides. We will get x is greater than negative 1 over negative 13 over 6. Okay, so here we have this so far, but we need to test the endpoints to see if they converge or diverge. So we set x is equal to, okay, so when x is equal to negative 11 divided by 6, plugging plugging this back into the summation is pretty simple. You'll see the pattern once you do these a few times. 6 to the n power, and then what was it? I think x plus 2. Yeah, x plus 2. Wait, where did I go? X plus 2 to the n power. Okay, x plus 2, when x is equal to this, 2 is equal to 12 over 6. So when we add these two together, like negative 11 over 6 plus 12 over 6 to the n power divided by n to the fourth power, we're going to get summation. This will give you, this right here is going to be a 1 over 6 to the n power. And this, they will cancel to give you 1 n to the fourth power. So here, we know this will converge because of a p-series. So converge p series, p is equal to 4. Okay, so when x is equal to, what's the other one? 13, negative 13 over 6 n equals 1. Negative 13 over 6. I'm not going to write it out this time, but if you add this to this, you're going to get what? Negative 1 over 6 to the n power divided by n to the fourth power. This can be equal to, n equals 1. Negative 1 to the n power divided by n to the fourth power. This will be convergent by alternating series tests, where, and since we're doing alternating series tests, we need to say 4 different conditions. So b of n will be equal to n to the fourth power, 1 over n to the fourth power. We have to say it's positive and continuous and decreasing because denominator is increasing, and the limit as n goes to infinity of b of n, which would be the limit as n goes to infinity of 1 over n to the fourth power, will be equal to 0. So since all 4 of these conditions are met, they will be convergent, or this will be convergent by alternating series tests. Since they're both convergent, we have to include both the endpoints. So we have to do square brackets. Negative 13 divided by 6, comma, negative 11 divided by 6. Okay. Use a 6th degree polynomial. Okay, so use the first few terms, blah, 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 to find this. Okay, so if we take a look at our formula sheet, which I don't have pulled up, I'm cooked. Where's my formula sheet? Do I have it? Hello? Oh, yep, I found it. Okay. We know sine of x will be equal to angle of n equals 0, negative 1. Good thing they have this on the formula sheet because I do not feel like memorizing all of this. 2n plus 1 factorial. Okay, so sine x will be equal to, let's plug in 0, right? If you plug in 0, anything to the 0th power is going to be 1, so we can ignore this term right now. And 0 times 2 is going to be 0 plus 1 is just going to be x. And, yep, and 0 times 2 here is going to give you 0 plus 1 is going to be 1 factorial. 1 is just 1. So plus the second term, if we plug in 1, we're going to get negative 1 to the first power is going to be negative 1. So we have to write a negative sign here. Negative, and then 1 times 2 is going to be 2, plus 1 is going to be 3. So x to the third power divided by, the bottom will be 3 factorial 2. Plus, when we plug in 2, negative 1 to the second power is going to be positive 1. So we have a plus sign. And then 2 times 2 is going to be 4, plus 1 is going to be 5. X to the fifth power divided by 5 factorial. Plus blah, 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 so on, right? But here we have a sine and then of x squared. This makes it slightly more complicated. So actually it doesn't really. We just replace every x we see with x squared. So the first x we see, we're going to replace that with x squared minus x squared to the third power divided by 3 factorial plus x squared to the fifth power divided by 5 factorial plus dot 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 so on, right? Now, we're estimating the value of the integral of this. So if we take the integral of both sides, right? If we take the integral of both sides, and it says to use the 6th degree polynomial, so let's not add the integral yet. Let's figure out where the 6th degree polynomial is. This is the 2nd degree minus 2 times, that's 6 divided by 3 factorial. This is the 6th degree. So this is all we need to go to. We don't need to estimate anymore. So we can say sine of x squared will be equal to this. Now we can take the integral of both sides. From 0 to 1, right? Now that we did this, the integral of both sides, 3 factorial is going to be equal to 6. This is going to be equal to 6 dx here, dx here. So let's solve this. The integral of x squared is going to be x to the third power divided by 3 minus, okay, what is this? X to the 7 power divided by 7, and 6 is already down here, so times 6. And we're going to evaluate this from 0 to 1. This will be equal to 1 over 3 minus 1 over 7 times 6 minus, and then we plug in 0 to each of these terms, those get 0. So this will just be our answer right here. Specifically, this will be our answer. Okay, find the partial fraction decomposition for this. Okay, so for this, let's just write it in the term that we know of, right? Where the highest power comes first, where 2x squared minus 3x plus 1. I want to write this a little bit better looking. Okay, now we need to solve this. How do we solve this? Let me think. Two terms that multiply to give you the side, but add up to become the middle. You're gonna get what? 2. You're gonna get negative. Yeah, you're gonna get negative 2 and negative 1. Because negative 2 times negative 1 will give you 2, which is what we want. So this will be, let's just look at the denominator for now. So this will be equal to 2x squared minus 2x minus x plus 1. Okay, so from here, let's group this stuff together. So this will be equal to 2. Actually, it'll be 2x, and then, oh, what is it? X minus 1 minus 1 minus 1, and then x minus 1. Okay, that's right, yeah. Now that we have this, this will be equal to 2x minus 1 and x minus 1. If we multiply this together, we will get this. Hopefully. I think we should. Anyways, so 1 over 2x minus 1 times x minus 1. Partial fraction decomp. Okay, so this will be equal to a over 2x minus 1 plus b over x minus 1. Multiplying both sides. I want to write this a little bit neater actually. 1. Multiplying both sides by 2x minus 1 times x minus 1. We're going to get 1 is equal to a times x minus 1 plus b times 2x minus 1. Now we set x is equal to 1. This term is going to cancel, so we're going to have 1 will be equal to 1 times 2 is 2 minus 1 is going to be 1, so it's going to be 1 is equal to b. If we set x is equal to 1/2, we're going to get 1 is equal to 1/2 minus 1. 1/2 minus 1 is going to be negative 1/2. Wait, what? That's kind of strange. 1/2 minus 1 is going to be negative 1/2. That's right. So it's going to be negative 0.5 a plus 0. This term will cancel. This is really strange. It's going to be equal to what? Negative 1/2 a. Okay, wait, never mind. A is going to be equal to negative 2. Okay, so that makes sense, I guess. So we can say f of x will be equal to a, which is negative 2, over 2x minus 1 plus b. B is equal to 1 over x minus 1. And that should be our answer. Okay, use the partial fraction decomp for part 1 to find the Taylor series center at 0. So this is a Macaron series. Okay, this is a pretty simple, not simple actually, it's a little bit complicated. But once we do this, I think it won't be too difficult. Okay, so we know that 1 over 1 minus x will be equal to, oh, what is it equal to? Oh my gosh, okay. Summation n equals 0, x to the n power. So okay, so it'll be anything to the 0th power is going to be 1. So it's going to be equal to 1 plus, if we plug in n equals 2, it's going to be x squared. Wait, 1, I mean, it's just going to be x plus x squared plus x to the 3rd power plus dot 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 dot, so on. Okay, so, but we have this here, so 1 over x minus 1 will be equal to negative of 1 over 1 minus x. Okay, so this will just be equal to negative in front of everything, dot, 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 so on. Okay, that makes sense. And then we have a negative 2 over 2x minus 1. This will be equal to a, we can bring out the negative 2 in front, right? 1 over 2x minus 1. This will be equal to a negative 2. You can bring out the negative, so it would be a positive 2, and then it would be a 1 minus 2x. So if we multiply everything here by a 2, like this, and then replace every x we see with a 2x, that should theoretically work. Or this one, I mean. So it'd be 1 plus 2x plus 2x squared plus 2x to the 3rd power plus dot 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 dot, so on. Now we just need to add these two together. Add these two together, and that should be right? I think. So, so f of x will be equal to, yeah, negative 1 minus x squared minus x to the 3rd power. This entire thing plus, actually we need to write it plus dot 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 dot, so on. Alright, plus 2, 1 plus 2x plus 2x squared plus 2x to the 3rd power plus dot 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 dot, so on. Okay, now that we have this, okay, I think we just do, so f of x will be equal to negative 1, okay, what is this, times this, negative 1 times, negative 1 plus 2 is going to be a 1, and then this will be a 2 squared, this will just be an x. So I guess we can write like, oh, this is kind of hard to think about, it's kind of weird to be honest, of 2, wait, this will be a plus 2x minus x, which we can write f of x will be equal to 1 plus, oh my gosh, what is this, 2 minus 1 x, yeah, that looks right, plus, oh my goodness, okay, this 2 and this 2, and this 2, so it's going to be 2 to the 3rd power, 2 to the 3rd power, so this will be 2 squared actually, be 2 to the 3rd power times x minus, oh, this will be x squared actually, x squared, and this will be x squared minus x squared. So this will be plus 2 to the 3rd power minus 1 x squared plus, this will be a plus, and then, okay, 2 to the 3rd power times another 2, 2 to the fourth power, 2 to the fourth power, times x to the third power, minus x to the third power. This would be plus 2 to the fourth power, minus 1, times x to the third power. Okay, plus dot 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 and so on, right? So f of x will be equal to the summation from n equals 0 to infinity. How do we get, okay, so we need to get this right here. This is in a form, you see the 2 is never changing, so we can just write a 2 here. But this is changing. The first one, or the second term right here is going to be a 2 for the power. So we need to do, second term is be 2, so you do n plus 1 here. The first term would be a 0. First term would be 1. 2 to 1 back. That should be right. Minus 1. And then x to the first power, to the nth power. And yep, that should be your answer, I think. It seems pretty right to me. Okay, that took a while. Next one. Find the center radius of convergence. Wait, what? Find the center and radius of the sphere. Okay, this is really easy. This is just complete the square. Square plus 2x. Now let's just rewrite the equation like this. Okay, since we spent a bunch of time on this one, we're going to speed through this one. So we don't want to be wasting time. That's never good. Okay, take this, divided by 2, square it. We're going to get 2 divided by 2, which is going to be 1. 1 squared is going to be 1. So it's x squared plus 2x plus 1. Plus y squared plus 4y. 4 divided by 2 is 2. 2 squared is going to be 4 plus 4. Plus z squared minus 6z. 6 divided by 2 is 3. 3 squared is going to be 9 plus 9 is equal to. Since we added 9 on this side, we added 4 on this side, we added 1 on this side, we need to add it on the other side. 1 plus 4 plus 9, which is equal to 14. Now, we did complete the square. This would just be pretty basic. X plus 1 squared plus y plus 2 squared plus z minus 3 squared will be equal to 14. So the center will be equal to -1, -2, and 3. And the radius will be equal to square root of 14. And this is our answer. This is center, 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 and square root of this is radius. Consider the line. So our direction vector, will be equal to the vector 3, -1, -2. And we're trying to find the unit vector. Unit vector is in the form of, oh shoot, what is it? It's like in the form of this, I think. Divided by the magnitude of v, like this. So, be 3, -1, -2. And the magnitude of this is going to be the square root of 3 squared plus -1 squared plus -2 squared. This will be equal to, the top stays the same, over 9 plus 1 plus 4, which is equal to 14 over our top. So this will give us, so u will be equal to 3 divided by 14, comma, -1 divided by square root of 14, comma, -2 square root of 14 divided by square root of 14. And that should be the unit vector parallel to the given line. Find the equation of the plane that contains the point. Okay, so we're given 3 points. We need to find the equation of the line. Equation of the plane. So for the equation of the plane, what do we need? We need to find two vectors on the plane. So if we set A, if this is A, this is B, and this is C, let U be equal to AB, which would be equal to B minus A, which would be equal to B, which is 1, 0, negative 3, minus A, which is 2, 3, 1. This will be equal to, what is this? Negative 1, negative 3, and negative 3 minus 1 is going to be negative 4. And let's set W is equal to AC, which would be equal to C minus A, which is equal to C is going to be equal to negative 2, 2, 1, minus 2, 3, 1, which would be equal to negative 2 minus 2 is going to be negative 4. Negative 2 minus 3 is going to be negative 1. Negative 1 minus 0. The normal vector for this will be U cross W will be equal to N, which will be equal to okay, I'm going to write this further down so we have more room. I, J, K, and W, where U, wait, what am I talking about? U is equal to negative 1, negative 3, negative 4. W is negative 4, negative 1, 0. This will be equal to I times negative, the determinant, we need to find the determinant of this. 3, negative 4, negative 1, 0, minus, right? Is it minus? It is minus, right? Right. I think. Minus J, and then negative 1, negative 4, negative 4, 0, plus K, because I think it switches signs, negative, positive. Yeah, it does. That should be right. And then negative 1, negative 3, negative 4, negative 1. So this will be equal to I. The determinant of this is going to be 3 times 0 is just going to be 0, 0 minus 4. Negative 4 times negative 1 is going to be 4. Minus J. 1 times 0 is going to be 0. Negative 4 times, so it's going to be 0 minus. Negative 4 times is going to be 16. Plus K. Negative 1 times negative 1 is going to be 1 minus. Negative 3 times negative 4. Negative 3 times negative 4 is going to be what, 12? So this is going to be equal to I of negative 4. And then this will be positive 16 plus J 16. This will be a minus K 12, which is also known as 4, 16, and negative 12. What am I talking about? I'm so stupid. This is 11. Okay, so now that we have this, we can write the equation of the line. Or equation of the plane. The equation of the plane is going to be the normal. So negative 4 times x minus a point. So this is the normal, so we can just do any point, I guess. Point is equal to, let's do A, 2, 3, 1. 2, 3, 1. For x minus 2 plus the normal 16 y minus 3 minus 11 and then z minus 1, which should be equal to 0. And that should be our answer. That's it.